Well, welcome to first-hand analysis of Apache NiFi vulnerability CVE-2023-34468. So before we get into exactly what that is, let me just introduce myself. I'm David Handerman, PMC member of the Apache NiFi project. I've been a committer for over 3 years now, so everything from extension additions to framework changes to security relevant fixes. So I've seen a lot in a few years and enjoyed it. I'm also a software engineer at DataVolo. DataVolo is powered by Apache NiFi, enabling and accelerating data engineering use cases, building pipelines for generative AI on structured and unstructured data. I also maintain a software development blog at exceptionfactory.com, where I've written about this vulnerability and other things Apache NiFi related and general software development best practices. So with that, what is the CVE? The title is Potential Code Injection with Database Services Using H2. Shorthand, Remote Code Execution, RCE. Everyone loves to see that in the headlines or fears to see it if you're on the receiving side. So I'll be going through and unpacking what exactly this meant for the project and how we dealt with it, and then some of the responses. So first, some facts and figures about the CVE. The NVD National Vulnerability Database score is 8.8 or 8.8 out of 10, which is a high severity, so hitting the red flags there. The reporter, Matei Badanoio, out of Romania, he actually has contributed several security findings, did a great job submitting a PDF that showed the step-by-step instructions to reproduce the issue. I authored the initial resolution, and as you'll see later, there was a bit more to it. The affected versions covered almost all of the versions of Apache NiFi up to that point, starting from 0.02 all the way to 121.0. If you want to see more details, there's the Apache NiFi Jira, has links to the GitHub pull requests and the details that follow. So today I want to walk through basically the timeline of how we addressed it, how we responded to it, and then again, some of the public reactions, some of the reporting around it made for an interesting case study. So first, the initial disclosure. Back over a year ago, June 6th, all of this happened on the same day, so this was kind of a best case scenario for us. First, the reporter sent an email with a PDF that documented step-by-step how to reproduce the issue. So he had screenshots, he had code samples, so it was very clear and easy from a developer and maintainer point of view to see exactly what the problem was versus just some security scan finding or some asserted issue without steps to reproduce. So as we do, this was sent to the security@nifi.apache.org alias, which is monitored by a subset of the PMC. We acknowledged receiving a report a couple hours after, basically when we got up in the morning, and said, thank you for the report, we'll look into it and get back to you. So after taking a couple hours, thanks to his detailed reporting, it didn't take long for us to confirm that yes, this is actually an issue. So we created a Jira issue and an initial CVE record in the CVE process.apache.org system. The CVE process, of course, being a private PMC only access system, the Jira issue being a public system. So of course, with open source, one of the challenges is how to address and remediate security relevant changes in a public way. What we've done in most cases, and did in this case, was provide enough general reasons to make this change, and I'll describe what those changes were further on. But basically had the tracking issue number and reserved a CVE number. We then responded to the reporter and said we acknowledge and accept this is a vulnerability. Here's the tracking number. We also provided an initial issue title for the CVE and a basic description to confirm with him that yes, this accurately reflects what I've reported. So that's an important part of the exchange, to say, okay, this is what you told me, this is what we understand, are we in agreement? So that went very well, and we proceeded to remediation. So that same day, I submitted a GitHub PR, and the PMC chair, Joe Witt, was able to review and merge that rather quickly. And the timeline, this reflects kind of the best of circumstances. We had actually already been discussing a 1.22.0 release candidate a few weeks prior. So we were able to move very quickly, even that same day, to preparing the release candidate build. Joe Witt acting as the release manager in this case. And then we follow the standard voting process, open for 72 hours starting on that day. The release voting completing on over a weekend, the actual release was the following Monday, so June 6th, roughly 6 days from the initial report. So we had both PMC binding votes and committer non-binding votes, but always helpful to get feedback and results and votes from the larger community. And then again, Joe Witt as the release manager released the version, followed the standard steps. And then after we made that release, then I clicked the ready button on the CVE process tool, and it makes a lot of the automated steps for reporting much easier. There's a way, it basically prepares announcement emails to the Apache announce list and our development announce list as part of the publication of that release. So coordinating both the new version of NiFi and the CVE went very smoothly. So initial release handled very quickly, everything's great, but more to the story. So first, before we get into the aftermath and what happened subsequently, let's talk about what the actual issue was. So in a nutshell, database drivers providing code execution. Now, of course, SQL provides all sorts of things, and usually that runs on the remote system. Well, in this case, H2, being an embedded database driver written in Java, has a lot of good qualities. It's been around for years, it's open source. It's no additional dependencies, it's high performance. It's not Apache licensed, it's licensed under either the Eclipse public license or the Mozilla public license, which has some constraints in terms of having to release back any changes. But NiFi used it for years, as noted from those versions since 0.02 and beyond. Notably though, as an embedded database, it can run standalone, but in our case, using it as an embedded database for writing events to the file system, it runs with the JVM permissions. So anything that the JVM and the user running the JVM can do, an H2 command can do. The reason that's important is user-defined functions. So like many databases, there's the opportunity and ability to create user-defined functions or triggers, and H2 being Java supports Java-based user-defined functions. So probably seeing where this goes, just an example of what you can do, create function, this runtime exec. All you need is a simple Java method. You can call the Java lang runtime, call exec, and it executes a shell command. Yes, lots of fun can be had, and you can see where this goes. So where did that then come into NiFi itself? So NiFi used H2 as a storage system for flow configuration events, flow configuration history, and I'll go into that in a minute. But the way the vulnerability impact came through was through database connection pools. NiFi has two of them, supported for years, the DBCP based on the Apache Commons DBCP library, and the Hikari CP implementation. Similar capabilities, connection pooling, a very common thing. But basically as a way to abstract relational database access. So you bring your own driver, you plug in the location, and you're able to connect to your relational database of choice. So the problem being, in this case, the H2 driver living on the file system, all it takes is referencing that path to that H2 jar, and you've now enabled any kind of code execution through that custom function. Then taking it a step further, so those were controller services. Those are referenced in NiFi processors, things to actually run SQL commands. So there's several of these, mentioned two of these here, execute SQL exactly as it sounds, insert, update, delete, put SQL a little bit more focused on just storing data with either insert, update, those kinds of things. And those processors have configurable pooling services, so you can plug in either the DBCP or the Hikari implementation. So just to visualize the vulnerable configuration, you have the processor connection pool referencing the H2 jar, and then the H2 library being able to execute custom user functions. So what did we do with it? So a combination of things, actually over several versions, first disabling and then deleting dangerous defaults. A little alliteration there for you. First thing, so in reaction to this report, we looked at it and decided that the best thing to do would be to disable the ability to do H2 database connections. Now, it is taking away a feature, but we viewed this as reasonable because NiFi, as a data transfer system, not a data storage system, the only real purpose for storing data locally is kind of a development or testing scenario. So that's why we didn't see taking away this or blocking this ability as a fundamental feature that we would remove and thus break any kind of deployed systems. So we initially based it on that JDBC connection string beginning with JDBC :H2. Every JDBC driver has a little bit different connection string, and so there's some level of assurance there. It's kind of simple, but it worked. H2 supports both in-memory and file-backed storage, so this covers both. And connection pool services and all NiFi components have a basic validation, a property validation interface. Most of those are, is this number in a port in a range, or does it match this syntax, that kind of thing. So we build a custom validation to say, okay, if it contains or if it starts with this string, the component is invalid, you can't enable it, you can't use it. So we also still retained H2 for that flow configuration history, that audit database storage, as had been up to that point. So that was the initial resolution. Again, just to visualize it, basically breaking that chain from the connection pool service to H2, and thus making it more difficult, at least through this path, to execute custom code. So that wasn't the end of the story, though, and thankfully the reporter came back and found another vulnerability that you could actually bypass the URL validation that we implemented. So that was unfortunate, ate a little humble pie there, but it was a good experience. So there are a couple ways. You could either insert additional characters, or you could use NiFi expression language, basically getting fancy and bypassing the validation. So we didn't address it. It took a little bit longer to turn around the release version, but we did see reported on August 3rd, released August 18th, went through the same process, confirmed the description, registering the number, went through the community vote and all that. This CVSS score was lower, not quite to the high severity range, but still a little above the medium of 5, and affected versions from previous to the one we had released after 123.0 as well. So after going through that, we decided to go even further, and for other reasons, which I won't go into all the details, we decided to move away from H2 completely. Some of that relates to migration and upgradability. If you've used H2, maybe you're familiar with this. If not, basically, as you might expect, when things are stored on the file system, there's a binary format. H2 made changes to that binary format in minor versions, and so thankfully we were able to catch that in the release review process, but we had to do some interesting workarounds to support migration and also upgrade to the latest H2 version. So that was fun. So there were multiple reasons why we decided to move away from H2 and instead went with JetBrains Exodus, which is, as mentioned there, a transactional schemaless embedded database, so not SQL, not JDBC, but file-backed, has transaction support for some consistency. It supports a JetBrains UTrack issue tracking service, and helpfully it's licensed under the Apache 2 license, so we were able to easily bring it in without any real concerns there. So going the extra mile, saying, all right, we've had enough with H2 for multiple reasons. And again, H2 is great for what it does and still very solid, but for our purpose and for what we needed to do, replacing it with Exodus was kind of the next step along this path. So those are the affected components. Let's talk a little bit about some of the mitigating factors and why this might not be as bad as it seems, but it's still worth addressing. So one of the important things to recognize, and things that got overlooked later, is that it required authentication in order to make these changes. NiFi requires username and password, or it supports SSO with OIDC or SAML in order to get in and even view the configuration, much less make changes. NiFi 1.14.0, going back several years now, we made default authentication and authorization required. This was an important step. We saw out there, I think there was a Twitter post one day saying, hey, look, I've found these vulnerable NiFi deployments running on AWS, and they're running plain HTTP. So, as much as you might put warnings in logs, or you might put warnings on downloads, it's easy to ignore those things. So we decided to take an extra step, do self-signed certificate generation and random username and password generation as part of the default install. So you download NiFi, bin NiFi sh start, you get that out of the box, so it's on the user, whether development, production, what have you, to turn off those security features. So that, again, was important. If you're running, say, NiFi 002, that wasn't there. But for any recent versions before this, out of the box, it required authentication. So if you can't authenticate, you can't even see the configuration, you can't even configure those vulnerable settings. Also, authorization. So again, local development, single user install, that's one thing. But in most, or any real production scenario, you want to have more than one user, multi-tenant, again, SSO, integration with LDAP or Active Directory, those kinds of things. So NiFi supports a managed authorizer, which lets you do fine-grained permission authorization. You can have it as general as, all right, if you're in this group, you can read the configuration. If you're in that group, you can write, and there's nuances there. But importantly, for any instance that was configured with the managed authorizer, you would have to have those right permissions on the configuration in order to configure that database URL, that H2 driver. So the initial CVSS score had the privileges required as low. So this actually has a big impact on the score. If those privileges required are set to high, that actually brings the score down. So again, numbers are only part of the factor, but it's worth highlighting that the privileges required are an important aspect of this vulnerability. So after it was published, the reporter also took it upon himself to make it available, and we talk about reproducible builds. There's also reproducible exploits. So if you go to packetstorm.com, you can look up the CVE number, and you can see the reporter authored this Metasploit module. As you might expect, it goes through, it creates a connection pool, creates a processor, and then launches a bash shell. So anyone, anywhere can download that and run it themselves. And they published that, again, well after we released, so it was the end of August, like 6 weeks after the CVE and the new version. So he didn't notify us, but we had no concerns because the new version was released. Again, in that Metasploit module, if you read it through, you'll see that a username and password are required. There's also another way to get a bearer token if you're in an SSO configuration, but either way, it's required to authenticate. It's required to have those configuration privileges. And also notably, the exploit itself required a Docker-based deployment using the convenience build of the Apache NiFi Docker image. That's important because the H2 library jar is in a different location depending on how you've built or deployed. So you can't just take, script kiddie approach, I'll just take and run this. It's not going to work, even if you had the credentials. It depends on how things are deployed. So again, details, nuances, but important to note if you're looking at the actual code. So now the reaction side of things. And as I put here, severity is not always what it seems. There's more behind the numbers. So this was interesting. After several months, so end of September, this organization, Sci-Firma Research, is based out of Singapore, but they have offices around the world. They published a report highlighting this exploit and providing some additional details. Notably, they focused on the vulnerability score. Of course, 8.8 reads pretty high. They had RCE in the headline, so of course that rises to the top. They also mentioned, they didn't cite the source of this, but several thousand deployed NiFi instances, trying to emphasize the impact. Again, I'm not sure where they got those numbers. It's great to know, and we're generally aware from community feedback that NiFi is used in a variety of industries all over the world, which is great, but of course if there's any vulnerability, there's an impact there. So again, that reporting gave a good summary. It highlighted also positively the collaboration from the Apache NiFi project and the reporter, so it was nice to have that encouragement. But most notably, it overlooked the access requirements. So it spent a lot of time focusing on the fact that this vulnerability allows you to execute code, but it didn't emphasize or didn't really note at all that you need to be authenticated. You need to be authorized with those permissions. Kind of important for one, reproducing the vulnerability, or deciding how severe it is in your installation. So then what happened? Well, there were a few kind of follow-on, copycat, or summarized articles. So CyFirma themselves actually puts out an audio podcast, basically a transcript generated. It was interesting to find. You can still find it on Apple Podcasts or other podcast systems, so they published that the next day. SecurityWeek.com, another article, picked up the research, and so they published an article similarly citing the RCE facts and also the exploit available. It was a little bit longer than some of the others. There were two other summaries, Cybersecurity News and OODA Loop was basically a paragraph just saying, here's the title, here's the vulnerability, not quoting the CVE description, which the CVE description mentioned authentication and authorization required, but summarizing the CyFirma analysis article instead. So, as you might expect, had a case of the telephone game. Now, who's ever played the telephone game as a kid? Is that all right? A few of you, so you know what that is. Basically, the more people you get, the more fun you can have. But you start off, one person has a word or phrase. They're supposed to whisper it to the next person. That person then whispers it the next, and on down the line. And then at the end, the person at the end is supposed to say, here's what I heard. And oftentimes it's very different from what the initial person said. So didn't have quite that level of signal attenuation here, but that kind of thing happened. So again, we published the CVE as the Apache NiFi project. The reporter published the Metasploit module. Again, very clear in both of those cases that authentication and authorization were required. But then you had the published security analysis of Metasploit module, and then you had others summarizing that security analysis. So again, it's interesting to trace back the provenance of this in its own right, but just the nature of reporting, the nature of what hits the headlines, what's most visible. So looking at that, taking a step back, you might ask, well, is it a bug or a feature? The classic question. NiFi actually supports scripted processors. There's an execute groovy script. There's even an execute stream command processor. Notably, these require the execute code permission in NiFi itself, so that's where the fine-grained permission configuration comes in. So one approach that we even considered early on is, well, you can do custom code. Should we apply the execute code permission to the controller service component itself? After, again, trading off feature sets and considerations, we decided, no, that's probably not an expected requirement for someone configuring a flow to say, you must have this permission. Now, we've had other discussions, and may change in the future, other discussions around NiFi itself and the level of permission configuration. There can be issues of things like noisy neighbor flow design when you have multi-tenants. And the same kind of thing could be true of security, where you might you want to block access to certain components but allow access to more trusted users. This is possible today, but it requires a lot of careful analysis of each component, as you might imagine, to decide which permission to apply. So again, why publish the CVE in the first place if custom code execution is a feature of some processors? Well, the thing we wanted to emphasize is that this is an unsupported code execution. Now, we could thought about having perhaps another connection pool supporting H2, something like that. Maybe you want to have custom code in your triggers or in your user-defined functions. That's still an option. You can still add your own, build your own extension component, load it if you have those OS level permissions to install that in NiFi. But that's something we did not want to support as the project itself and as a first-class feature. So that was just some of the analysis, some of the consideration that went into whether to publish, what to say about it, and what remediation to implement. So to summarize, read beyond the score. Again, 8.8, it's high. RCE immediately trips the level of concern, as it rightly should, but the details are very important when you're analyzing a CVE, when you're, especially whether as a consumer or even as a project maintainer. We've iterated over this on the NiFi project as well, how to score things, how to describe it, how much detail, and it is a case-by-case consideration. But especially as a consumer, especially as looking out there in the security world, it's important to go beyond just the numbers, go beyond what some scanning tool may tell you, and actually use the source, as we're all want to do. And again, another value of open source development, being able to actually see what is the code path. Are we even using this code path in our software? So with that, thank you for your time. I'm glad to take some questions. Again, my blog, exceptionfactor.com, I have a blog post on this if you're interested in more. And thank you for your time.